Hi guys, welcome to Preliminary Chemistry and the Metals video series. We're going to be looking in this one again at uses of metals. We've touched on this before, but trying to link some of the uses into their different reactivities. So just to recontextualize what we're doing, we first looked at metals in the context of their discoveries, and we said that most of the discoveries were based on their general activity. That is, the least reactive metals were the ones that were more likely to be found uncombined and therefore in their native state. And most of these were relatively stable. They weren't breaking down, and some of them were valuable, such as gold. So we have silver and we have copper and a few other metals that are low on the activity series, and these were the ones that we discovered. It was later, when our technology improved, that we were able to find the more reactive metals, because these ones were already combined in compounds, and learned the techniques that we needed in order to refine those metals and to recover them from their ores. So in our modern day, we have a range of different types of uses for different metals, which are again based often on their activity or their reactivity. The problem is metals in the air are exposed to oxygen. Some of them are used to transport water or other types of chemicals in liquid form. This can include things like detergents. It also includes things like acids, and sometimes metals are chosen for the transport of these particular materials as well. They can also even be used in things like human bodies as replacement body parts. Which particular metals that we're going to choose for their transport, their stability in oxygen, their ability to transmit electric current, or in human body part replacement is based on a number of factors, but one of these important factors can be their activity or their reactivity. So here's a quick table just to give you a bit of a comparison of how we might make decisions about which types of metals we use for different purposes. So the first one might be for home roofing and guttering. Now you will find that aluminium is a good choice here. It's an active metal, but the oxide that forms is very, very stable. And as a consequence of that, it's a very good choice in terms of its formation of a very stable coating for things like gutterings. But it's very expensive in comparison to something like steel, which is an alloy of iron and which is less expensive but has that tendency to corrode. Corrosion is the big problem which is always going to be relevant for iron. Just because of the nature of iron ores means that iron will corrode, and when it does, it doesn't form a very stable coating. It forms a very, very porous coating, and it means that once the rusting process starts, it's very, very difficult to stop. For water pipes, same sort of thing. We've now moved into a replacement material. Polymers such as plastics are often more commonly used for the transmission of water. But we did have choices about whether we would use copper piping or, again, an alloy of iron. In this case, copper is the less reactive metal, and so therefore it's more stable. It's less likely to combine with any oxygen or the water itself in order to corrode. But in comparison to what we can create with iron, copper is again a little more expensive. So iron again could be a choice, but you have the same problem that you had before, which is iron corrodes. In microcircuitry, when we're looking for conductivity, copper is obviously a very important conductive metal and is relatively stable, except when we compare it to gold. Gold is very, very low in the activity series, and so it's an extremely stable metal, but as you'll be aware, the problem with gold is its cost. It's very expensive. Now the amounts are small, and you probably find some gold in your mobile phone if you pull it apart. And in fact, they do talk about the amount of gold that's being released into landfill as a consequence, and not just gold either, of some of these important, expensive metals that are present in microcircuitry like mobile phones. But the amount is very small. And again, then here we have another consideration based on what is important when we're considering a use. And the final one to just have as an example to throw out is for implants. This can include things like teeth, replacement joints like knee joints. Titanium alloys are often the ones that are being chosen. They're extremely strong alloys, and again, they have low activity. They don't break down. They're very, very stable in the body. But as with some of the examples we've previously looked at, the problem with titanium alloys is their cost. Again, stainless steel is often the one that's chosen for the job because of its low cost. But again, we still have this problem of corrosion, which can creep in and can affect our iron alloys. So these are some of the considerations to think about when we're trying to match our metals with a particular use. Thanks for watching.